Lindsay. So as Lindsay mentioned, my name is Kristen Loria. I'm a program coordinator with the New York Soil Health Program, which is a program of Cornell Cal's. And we're based in Ithaca, but work statewide. We hold a lot of outreach activities, soil health field days, throughout the summer especially. And we coordinate the Soil Health Alliance, which is brings together all sorts of agricultural practitioners and farmers around the state, all to work on improving soil health here in New York State. So if you're not familiar with New York Soil Health, definitely check us out. We have a really nice website with lots of good resources. So I'm going to go ahead and share my screen here. All right. Okay, does that look good for everyone? Great. And so, yeah, a little bit more background about myself. So, I have a master's degree in plant genetics and breeding, actually, where I worked on some sort of on-farm trialing now with New York Soil Health, obviously working more in agronomy and soils. But I also lead our on-farm research program at New York Soil Health. And prior to completing my master's at Cornell, I was a vegetable farmer, so I feel that there's a lot of overlap maybe in how cover crops are fitting into flower systems compared to small vegetable production, which was my background. And actually, I'm still farming. I now grow dry beans, and my business is called Buttermilk Bean. So I have been in agriculture quite some time now and happy to be with you today. So we will get into it. So maximizing cover crop benefits. And just a quick flash up on the screen. These are our soil health field days for the summer, as I mentioned. It's a lot of text, of course, but if you go to our website, um, just some highlights. We will have some events more focused on smaller scale production, in particular Albany County. Um, Coming up August 4th. Also Long Island. There's some sort of vegetable nursery, more specialty crop focus in mid-July. So yeah, check this out. See if there's anything near you that might be of interest. But we have a lot of great events this summer. So yes, back to cover crops. So what exactly is a cover crop? So I think most of you are familiar with cover crops, but essentially it can be a little bit of a gray area, but really these are crops we're not harvesting to sell. We're planting them primarily for their soil health and other ecosystem benefits. And of course, it's important. Farms are businesses, and it's important for us to manage our cover crops in a way that are maximizing their benefits most efficiently and not compromising the profitability of our farm enterprise because we're always trying to do a million things on our farms and we want to get the most bang for our buck from the cover crops that we're planting. And so essentially, cover crops are filling the temporal windows in our growing season where the soil would otherwise be fallow. And in those fallow periods, we're really just missing out on a lot of potential, essentially plant biomass accumulation and all the associated benefits between the cash crops that we're growing. So this is more of like a grain rotation we're looking at here, but you can see there are large periods sometimes across that sort of 3 year rotation where there might not be a cash crop growing. And so the idea of the cover crop is to really maximize the potential, essentially soil energy or solar energy that we have to use in those fallow periods. And so, what sort of benefits can we manage for when we're planting a cover crop? Um, Spoiler alert, there are many benefits, but it's important when you're thinking about cover cropping to start with, well, what is most important to you? What makes sense in your farming system? And so, often what we think about first and what's really important is soil health. And some of the components of soil health, specifically that cover crops are supporting, are adding organic matter. So, because that cover crop is generally returning to the soil, that is one of our best ways, besides adding compost, to improve our organic matter. and replace the nutrients that are being pulled out of our soil and harvested. Soil aggregation is also huge. So essentially, the more living roots you can have in the soil, more often, the better soil aggregation you'll have. Um, Related to that, mycorrhizal numbers. So those are beneficial fungi that live in our soil and give a lot of benefits to plant health and soil health in general. They love living roots, and that's what they're going to be best sort of encouraged by. And then nitrogen. Some cover crops can add nitrogen to our systems. Cover crops can suppress weeds, sometimes suppress pests such as nematodes or certain fungal pathogens. Um, and keeping the soil covered, reducing erosion, um, decreasing compaction, holding on to nutrients during fallow periods, not letting them to be lost through the soil surface. These are all benefits that we can manage for in our cover crop decisions. And so, first off, a really common reason to plant cover crops in both organic and conventional systems, but certainly in organic systems, by our sort of management tools, such as cover cropping, kind of comes to the forefront. We might not think about it because oftentimes we're looking at weeds in our crop after our cover crop has long been tilled under, but cover crops can be really effective at managing weeds. And that's because, in a few different ways, but most importantly, they're competing with the weeds when you don't have something growing there. And so, if you plant a nice, thick cover crop, till it under, and then plant your cash crop, that cash crop basically has the best opportunity it can to establish itself and get ahead of the weeds before they outcompete. The cash crop. And so you can see in that picture, that's actually a field where on the right side, no cover crop was planted. On the left side, cover crop was planted. It was all plowed. It was all planted to soybean. And you can see the legacy of that cover crop. And that is mostly competition for resources. Some cover crop species, like cereal rye, actually have chemical mechanisms that suppress the growth of other plants. And that's called allelopathy. And also often once we terminate a cover crop, especially if we're doing no-till, we have a nice mulch on top, and we all know that mulch is very effective at suppressing weeds. And in general, our grass species like cereal rye, a sorghum Sudan, um, are going to be really effective at competing with weeds. Brassicas such as tillage radish or turnip, maybe mustard also are quite effective at competing with weeds. So those are kind of the two plant families you would go to if you have a bit of a weed problem and you really want to get ahead of it, is those, we often call them kind of smother crops. And next up is soil aggregation and tilth. And really, the key here is living roots. Soil aggregation is a really fundamental part of soil health and healthy soils. I think we all know the feeling of like a really nice soil tilth. You dig your hand in there, it's crumbly, it kind of holds together. You don't want to see any of the surface crusting. That's a sign of poor soil aggregation. And really, the key to getting good soil aggregation is living roots. So, soil aggregates are made up of plant roots. They're made up of fungal hyphae, which are just kind of the fungal structures in the soil, as well as different biofilms or polysaccharides that are being released by our plant roots and the soil microorganisms that are living amongst them. And so, really, the higher living root biomass we have, um, in our soil for more of the season, the better aggregation we will see. And this is just sort of a visual of what you might see. So here on the left, this is over 10 years of cover crops in a Concord grape vineyard. You can kind of see that blockier, crumbly, more crumbly structure. Look at all those roots that really are like kind of, the roots are sort of like the backbone, right, of those soil aggregates. And then without cover crops, There's just a lot less living in there, and that soil is going to be much more difficult to work and harder to um, grow grow your crops successfully in. And so we mentioned mycorrhizal activity. So this is just, we won't spend too much time on this, but essentially those mycorrhizae, we really want those in our soil. They're really beneficial. They often are forming symbiotic relationships with our cash crop roots. And so that we want as many of those associations as possible in our soil when we go to plant, our flower crop, our grain crop, whatever it is, because those associations between the mycorrhizal fungi and our crop roots are very beneficial for the health and the kind of nutrient provisioning of the plants in that soil. And the other piece of encouraging mycorrhizal activity is reducing tillage. So we're not going to talk about that too much, but those fungal structures are what are sort of most vulnerable to tillage in the soil. So a lot of soil structure will be maintained fairly well if you're tilling at the right time. It's not too wet. But the mycorrhizae are disturbed by tillage. So those are kind of two compete important factors to encouraging that activity. And an interesting thing about AMF, which is just those mycorrhizal fungi that we're talking about, is that grass and legumes really support the colonization and activity of those species. Brassicas don't. So you can see down here, fallow soil has lower amounts of these fungi, and they're just as low or even sometimes lower in the brassica. So brassicas have great benefits to our systems, but species like canola, radish are not going to improve our mycorrhizal populations. But a great reason to use mixtures where you can kind of balance benefits of different species. So that's sort of a deep dive into some soil microbiome aspects, and this is just a cool close-up of what those fungal hyphae look like in association with a plant root. So this big yellow thing is a plant root. These are the fungal hyphae, and they're actually see they're chatting with each other, and actually those hyphae are helping the plant access phosphorus, which can be a limiting nutrient in our soil, and those fungal organisms are better at accessing sometimes than plants themselves. So good stuff, hard to see, right, with the naked eye, but important aspects of building soil health. And cover crop roots are just sort of one piece of the puzzle, but an important piece for supporting that soil health. And reducing nitrogen leaching. So this is another benefit. As you can see in this figure, when your field is fallow, it's a really leaky system. And so cover crops are going to be able to hold those nutrients, in particular nitrogen, which is quite mobile in our soil profile, hold those nutrients between your cash crops, often over winter. Those early spring months can be kind of a leaky period as it's warming up, but before we're really growing. And so fallow field, you'll get the most leaching. And after that, legume species also, because they are making their own nitrogen, they aren't as kind of hungry for nitrogen in the soil. Sometimes you can have some nitrogen leaching even with a legume cover crop planted. But the grasses, the radish, the canola, and the mixtures are really effective at holding on to that nitrogen and allowing it to, they basically are pulling it into their tissues. And so if you're incorporating that cover crop right before you plant your cash crop, that is usually a really good sort of release opportunity for those nutrients to be available in the soil right when you want them to be available. And so legumes are providing that biological nitrogen fixation, which is a great service. Peas, clovers are really excellent fixers of nitrogen in our agricultural systems, especially useful if you've applied a lot of compost or manure. Maybe you have an imbalance of too much phosphorus in your soil. Want to be doing these soil tests every year, ideally, and getting a sense for your nutrient balance. But we can use these cover crop sources of nitrogen to increase our nitrogen availability without getting sort of an overload of some of the other nutrients that might come from manure or compost sources, which I know often in small scale production, we need a lot of fertility, and those materials are used very readily, but sometimes balance can get a little out of whack. And so legumes are a great tool if you find yourself in a situation like that. And on the flip side, if you're in a somewhat nitrogen limited environment, cover crops can compete with cash crops for nitrogen. And that is more of a problem in sort of no-till scenarios where you have a lot of cover crop sort of mulch that's going to stay on the surface. So cereal rye is sort of infamous for that. And you can see here this figure is just showing corn silage yield. So, yield of whatever crop it might be. We see the legumes resulted in a highest yield, the cereal rye resulted in the lowest yield, and that was because that corn was nitrogen limited. So the cereal rye actually tied up nitrogen in its biomass that was not released in time for the subsequent crop. And that's because it has a very high carbon to nitrogen ratio in its plant tissues. And that is what's going to sort of cause that holding up of nutrients. And so carbon to nitrogen ratios are an important thing to think about if you're worried about nutrient availability, if you're going to be planting a crop that needs a lot of nitrogen. It's something in particular to think about. And this just so every plant tissue, outgrowing in the field is going to have a percent of carbon and a percent of nitrogen. And the ratio of those two percentages is our carbon to nitrogen ratio. And this is important because the microorganisms in the soil sort of need a bit of a balance of carbon and nitrogen to break down those plant tissues and make those nutrients available to whatever crop you're going to plant afterwards. And if it has a really high proportion of carbon relative to nitrogen, they're going to sort of run out of nitrogen before they break down all the carbon. And that means they're going to suck all the nitrogen out of the soil to complete their biological processes, and there won't be any left for the crop that you're planting also. It also can kind of slow decomposition because that material is sort of bound up in all that carbon without enough nitrogen for the microorganisms to break it down. And so we see that most again in those grass species. And it's kind of interesting because, so this hopefully you've kind of figured out this figure is showing the spectrum from really high carbon to nitrogen, where those microorganisms are sort of starved for nitrogen, and we call that nitrogen immobilization. Um, and that is most often going to happen in grasses. At the other end of the spectrum, when we have excess nitrogen, we'll see that in legume species like clovers, peas. Um, those are having a very low carbon to nitrogen ratio, and so there'll be quite a bit of nitrogen released from the decomposition of that material. And something that's important is cereal rye kind of gets a bad rap for tying up nitrogen, but you'll see how wide the spectrum is there of possible carbon to nitrogen ratios, and that's because the stage of the plant um, at which it's plowed under or crimped or mowed is going to have a huge effect on the carbon to nitrogen ratio. So if we let our cereal rye get 6 feet tall and it's about to make seeds, it's going to have a very high carbon to nitrogen ratio. It's going to be in that orange-brown area. But if we terminate it when it's shorter, maybe right when it's starting to elongate or before it's made a flower, it started to flower and head out, it can actually still be a really great source of nitrogen. So grass cover crop species are not always negative in terms of their ability, their sort of the risk of tying up nutrients in your system. They just have to be managed correctly. And so you have to think about the timing of when that cover crop is going to be terminated. And not if you're concerned about nutrient tie-up, not letting it get absolutely massive and overly mature. But building organic matter is where those, 6 foot tall grasses are really going to shine. And so it's all about trade-offs, right? There's no kind of perfect silver bullet cover crop species that will do all the things in our web of cover crop benefits. But in general, those really high biomass cover crops are going to provide faster accumulation of organic matter in the soil. And I should have talked about it on the last slide, but essentially the sweet spot of carbon to nitrogen is about 20 to 30. And that's right in the middle of that spectrum figure we were looking at, where the microbes can do their thing, return a lot of that carbon to the soil in a more stable form, build organic matter, but not be starved of nitrogen to perform that function. And that's particularly important on lighter textured soils where it can be a real challenge to build organic matter and you're seeing losses of organic matter each year. One option, adding compost will build your organic matter, but incorporating, mowing down, uh, plowing under really high biomass cover crops like this. This is sorghum Sudan grass in the picture here, along with sun hemp. Um, is going to build that organic matter. And I won't touch on this too much, but cover crops as biofumigants, there's some species of mustard and also Sudan grass that can have effective biofumigate properties if you have a particular disease issue or nematode issue. Um, they can be one management tool. So that's pretty amazing, pretty cool. Um, and yeah, we've been talking a lot about individual species, right? And you might be thinking, well, like how often do I really plant one species? I'm planting mixtures. And if you are, that's awesome because as we talked about, there's all these trade-offs of the different species. This is a spider plot. This is one way we kind of visualize the benefits that the cover crops are giving us. And if we're combining, as you might imagine, the rye and the pea in one cover crop, um, we have the ability um, to get both benefits, right? And so that's why here you'll see overlaid is a mixture. So that is a mixture of rye, pea, and some other mystery species we don't know. But that's covering the greatest area of the spider plot, meaning we're getting the most sort of overall benefit versus just using a single species. Sometimes a single species is great if you know what you want from that cover crop and that species can do the best job. That's awesome. I think people sometimes go a little crazy with like 20 species mixtures, and often we see that 3 species can usually cover all the benefits that you're going to cover. Maybe if you're going for pollinator benefits, some more supplementary benefits that might make sense to do more. But oftentimes combining a grass and a legume, maybe a brassica and a legume can be beneficial and sort of as much diversity as you need. So it's kind of thinking about those different species as like functional groups more than needing, tons and tons of diversity all at once. And so I think we've been talking about already a lot, sort of how we choose the cover crops when it comes to different goals. So I'll probably kind of go through this a little bit um, faster, but essentially it can be a little overwhelming, right? We have like a million cover crops available to us. They're all beautiful, they're all cool looking. We want to plant them all at once. But but how do we actually decide, right? How do we narrow it down? And so the thing I sort of mentioned just now is sort of functional groups is a really helpful way to sort of categorize the species and narrow down what we want. So nitrogen scavengers tends to be grasses and brassicas. Green manures are gonna, clover is, hairy vetch clovers are sort of cream of the crop, green manures. Smother crops, buckwheat is really famous for doing a great job at just like jumping out of the ground, smothering the soil, covering the soil, and doing a great job competing. Um, Buckwheat's great for sort of short windows that you might have in the season, especially in like a complicated flower cropping rotation. Buckwheat could be a really great one. Um, or a biofumigant is sort of another like family of cover crops. So yeah, of course it's knowledge intensive, right? And so it's good to sort of take advantage of the resources out there to figure out what makes sense for your farming system and maximize, like we said, sort of maximize the benefits you can get in those short windows we have available. Here in the Northeast, we have fairly short seasons, and that can make maximizing our cover crop growth challenging. But there are definitely ways, kind of knowing what your goals are and knowing the best way to manage and get those cover crops established is key. And so one resource I would absolutely highlight, if you aren't familiar with it, it's a free resource. It's available on the SARE Northeast SARE website. It's called Managing Cover Crops Profitably, and it has a lot of it's a you can kind of have an interactive PDF on or interactive web experience on the website, and then you can also buy a book copy. But this has everything you need in terms of, well, what time of the year am I planting? What are my options? What are seeding rates? How much would I expect to spend on the cover crop? So these sort of reference tables are hugely important when it gets down to actually the business of cover cropping. Another resource, we have a resource. So this is on the New York Soil Health website. This is a large acreage edition, but we also have a more general edition. And so this is just like a nice quick reference chart that is tailored to New York State growing environment. And so these seeding rates, the timing, all of these things are calibrated to our growing season. And so yeah, small scale production. I'm assuming most of you in flower production are working at a relatively small scale versus like a field crops scenario. And so we'll dive into that just really quickly. And so yeah, I think this has come up a couple times now, but defining your goals, defining the constraints. You might be planting, I don't know how many species you all plant, but you plant a lot of species every year. I'm impressed, like what, 30 species, probably more. And so you probably have a million different windows of sort of fallow periods, cover crop or cash crops being taken out of the ground at different times and turned over. And so those sort of quick reference charts are going to be really great for seeing what you can kind of fit in. So starting simple, picking even if it's just picking one or two species that makes sense for your farm and are easy to start with. Starting simple is absolutely key sometimes. And as much as possible, treating your cover crop like a cash crop. That's how you're going to get the most bang for your buck. So sometimes buying varieties that are actually named varieties versus VNS or variety not stated. This is important, especially for annual ryegrass, which can kind of be all over the map in terms of what you're actually getting. Inoculating legumes if you're planting legumes. Um, Planning the correct rates, not underdoing it, and taking advantage of your local resources. So NRCS and soil and water districts will often pay for your cover crop seed if you're working with them and can give you great advice, sometimes providing equipment. Some soil and water districts have equipment that you can borrow. So there are really good, generally good kind of boots on the ground resources to support and help pay for this because everyone knows it's a good idea, right? So they want to support you. And I think we already looked at this. So methods for terminating cover crops, right? You have to figure out what you're going to do with that cover crop after you plant it and grow it. And so typically mowing, this is a flail mower, I think, which is excellent because it breaks down the cover crops into really small pieces and makes it easier to incorporate into the soil. Of course, tillage is is often key. Here's some interesting ones, and I imagine a lot of you or some of you might be using tarping, right? So a lot of work was done by University of Maine as well as Cornell Small Farms program looking at tarping. There's a really awesome guide on tarping, and they did a lot of work with rolling a cover crop first and then tarping it, and that found that to be a really efficient way of terminating a cover crop and then planting into that residue. So that's a cool one. This is the website there, University of Maine Bulletin. Um, the Small Farms program also has great resources for that. And so, yeah, because reducing tillage in vegetable systems can look really different than sort of field crop scale, where your equipment might be different. And your goals might be different. So tarps can be a great kind of combination with cover cropping and allow smaller scale operations to more effectively cover crop without, being stuck in a situation where they can't effectively manage that cover crop. And just lastly, really quickly, are co some cover cropping decision support tools that are online that can be really helpful. So books are always really nice and handy, but these are much more interactive. So this is hosted by the Northeast Cover Crops Council, um, another great website and resource for us here in the Northeast. And they'll kind of walk you through the process of selecting your location, defining your site conditions, picking those cover crop goals, right? A lot of what we talked about, defining your cash crop growing window, and then boom, it pumps out for you what cover crops might be best, given all those parameters. So this is a really great tool and fun to play around with. So I encourage this is great winter fun activity for you to check out. The same Cover Crops Council also has this cover crop nitrogen calculator, which is often more calibrated towards field crops, maybe less useful, but also something that's interesting when you're thinking about sort of how that cover crop is being translated into nutrients after you incorporate it. So I think that's about all I've got. I'm wrapping it up here, and I know you all generally have great discussion following, so maybe we can just move on to that. And yeah, we have a great email newsletter that goes out, so check us out on the website, join our listserv if you're interested. And these are some free resources that you can all find on our website related to soil health, soil science, cover cropping, reducing tillage, all that good stuff. We that's what we do. So with that, I will